These are some things we're going to go over today, starting with how this project began. Heather Bednarz was the inspiration for this project. She's an occupational therapist who sees firsthand her patients suffering from pressure ulcers. There are 4 stages of pressure ulcers. The first appears to be red irritation on the skin. The second is more of a blister. The third is an open wound that goes down to the tissue. And the 4th stage is the most dangerous stage. It goes all the way down to the bone. 2.5 million people each year are affected from pressure ulcers, and 60,000 of these people die as a direct result from these ulcers. Our goal is to make this 100% preventable, because it is. Changing pressure, these pressure ulcers don't occur. So we're gonna create a system that will redistribute this pressure, show where this pressure is at, while also reducing cost for this project, for the patient and the healthcare facility.
All right, so this is the expenditures. We became extremely fortunate in the fact that a couple of our parts got donated. For example, the aluminum plates. And no, that is not a typo. Our wheelchair was only $3 for our project. So when you look at the total cost of all of our components, the total cost of our project was roughly $730.
All right, so for those of you who weren't around for last semester, just as a recap, we started off with our main idea with the inspiration from Heather Bednarz. We were then able to look at our project and say what we needed to do. So we started off with 2 aluminum plates, each an 1/8 inch thick. We were then able to mount them to the wheelchair and place our load cells on that plate to ensure that we were able to sense this pressure in the seat. From there, we placed 2 manual air bladders on the back of the seat to allow the patient center of gravity to be shifted. This is how we were going to change the pressure of the seat initially. From there, we were able to also introduce our LED display, as you can see up to your right. From there, we were able to create a system, next slide, that will tell us how long the patient has been in a position and where high pressure is. So as you can see at the top, we have our normal system, which is your 3 green LEDs, which then has 1 yellow solid LED. This is just telling where the high pressure point is. There's nothing that's necessarily wrong. It's just saying where the patient's highest pressure point currently is. After a given amount of time, this will then change to a blinking LED. This is, again, nothing is wrong, but it's saying that the patient has been in this position long enough for them to possibly be on their way to developing a pressure sore. It is only until this blinking LED turns red that it tells the system or the administrator that they need to move because they're in danger of having a pressure sore develop.
So this is our new design. The biggest change we made is that we moved the air bladders from the back of the seat, back of the wheelchair to the seat. We have 4 air bladders, one placed on each quadrant of our chair to relieve the high pressure points. Also, our pump assembly is installed into a case which is mounted behind the wheelchair, and the hoses that are connected to the air bladders are connected to the bottom of the casing. Lastly, for our circuitry, we moved everything from solderless breadboards to printed circuit boards, and these circuit boards are mounted into various positions inside the case, and our LED display is mounted onto the lid of the case, and as you'll see in the demonstration, the lid of the case is made out of plexiglass, so you can see the display.
So this is our automatic air inflation system. It's comprised of an air compressor to inflate the air bladders, 8 solenoids, 4 of which are inlet valves to allow the air bladders to inflate, and then the other 4 are outlet valves to release air pressure from the air bladders. There's also 4 air pressure sensors, which continues to monitor the air pressure in each air bladder, and this is all controlled and monitored by a microcontroller. So the way it works is, when the microcontroller detects a high pressure quadrant, it'll inflate the air bladder in that quadrant. Right after that, it will deflate an air bladder in the quadrant opposite of that. We do that to ensure that the patient in the wheelchair gets maximum redistribution of their pressure. That process will continue until the high pressure quadrant is changed. It's also important to note the air pressure sensors are vital to the process because they monitor how long the air compressor runs for.
All right, so now we've covered a lot of things that we went through throughout the semester, what we're trying to achieve, and what we're trying to do with this project. But the real question comes down to, are we able to make it work? Well, we're going to find out right now, right here. Can I volunteer? Bednarz? He's going to be our test stop. So he's the shell, right? So whenever I'll turn around, I'm going to work you through the whole process of it. All right. So right up there, right now we turn on the system. The first step in this whole system is the calibration process. This is when the system uses a person's weight to remove every single air from the air bladders. So this avoids overinflation and all that. The next step is to have the LEDs turn on, which they should be coming on right about now. There you go. Right now it's showing the yellow high pressure point right here, which is where Dr. B's leaning a little bit too. And then it starts blinking after a couple minutes, and then it turns to red. Once the red turns on, it turns on the air bladder at that exact location to try and displace its center of gravity more towards the left side. As you can see, it's slowly working right now. Now it's on the red side. Now you can see the left side is showing a high pressure sensor point. This is showing where the more pressure is right now because it's on this left side. As you can see, it's blinking right now, and it's going to turn to red, showing the high pressure point. Once the red turns on, the air bags turn on, and try to shift the center of gravity more towards the center. Thank you. That's it. Dr. B for being our advisor for this project and our test dummy for this. Just kidding. We also want to thank Heather Redistribution, Dr. B's wife, for being an inspiration for our project. We want to thank Dr. Zhu for our amino control, which are the main and vital part to this project. We also want to thank SNK Sales. They donated the aluminum plates. We can all agree nothing's better than free 99. So, we also want to thank Rich Adams for all the manufacturing and fabrication helping us put this wheelchair. He's a wizard with any manufacturing thing we need. And we also want to thank Dr. Gilmer. Oh my. I want to thank you for all the work you're doing for us, Dr. Gilmer. And our best. We're going to work problem statement. What we did last semester, the improvements we made this semester, and we also gave some acknowledgement to the guys who helped out throughout this whole project. We also want to thank our parents for putting up with us throughout the whole semester. I know a couple of times it can be annoying talking to us while working on this, but we thank you for keeping it cool with us, and we give you a live demonstration. I'd like to open up the floor for any questions now.
So I'll go ahead with this. So as you see, a lot of the things on here are definitely a prototype. It's a proof of concept. So the things we need to refine is definitely making printed circuit boards more encompassing and making sure that we have a more appropriate case. Honestly, there's not a whole lot that needs to be refined. It is obviously, as you see, functional, but we would definitely like to improve upon some things. So there's only 4 load cells. We would eventually like to get closer to maybe 16 to ensure there's more accurate resolution where the high pressure is. As you can see, it's also mounted to the wheelchair. We could possibly expand this to go somewhere else beyond just wheelchairs to even a normal seat, like a couch or something, or ladies Susan. A recliner, please avoid. Could go on Lady Susan, wouldn't do very much good. But yeah, it's really the manufacturing. It's just a matter of getting the final design set up. I mean, it's all here, the code's done. It's just a matter of whether it's compatible.
Do you have any idea how much a system like this would cost as an add-on to what a wheelchair would cost, as you know, as a final product?
Oh yeah, well, while doing this research, we found something online. It's called a specialty positioning device. All that is basically is a wheelchair that it just follows a constant loop. There's no sensing aspect and there's no redistribution. It just follows a constant loop. And that wheelchair itself costs about $1,700. Ours is, like you see, $730. So, you know, with some labor and using some parts were donated, so we have to factor that into it. I'm assuming somewhere around $900 is what we're shooting for, which is a lot less than $1,700.
What do you think will be the next step to get this FDA approved?
We work with them.
I mean, yeah, just
Definitely, one thing that someone's brought up to us in the past is the noise from the compressor. You know, if someone's in a nursing home and not all there, it could scare them, so it would be that. And one solution we had to that would be using pre-filled oxygen or compressed air tank that would just send out pulses of air as compared to a compressor cycling and running.
What was the hardest part of this project for you?
For me, it was definitely just getting all together and just putting everything together in the final product. We had everything working individually, but definitely the most time-consuming process was putting it all together on the wheelchair.
What was the energy capacity of the battery you had? How often do you have to charge?
We're using a 12-volt, 3-amp-hour lead acid battery. We didn't come up with any kind of charging circuit for it, or really think about that, because that would kind of be out of the scope of the project to make a pressure redistribution system. So we really didn't go into that very much.
But if I would like to expand on that, it would be ideal if we could do something like a rechargeable lithium-ion battery, so then we can just plug it right in, and it would be easy to fix. And then that way, there's no issue with having to replace batteries, just like when the patient's no longer using it, and let's say at the end of the night, they just plug it in, the next day it's good to go. So that would be a future expansion we want to take.
Other questions? Is this something that you guys plan on selling like as a kit that you can attach to previous existing wheelchairs, or is this something that you plan on just selling as an entire package?
Well, the main focus of our project is to create a system. The wheelchair is just our frame for the system. So this is, as you say, it's a kit, and we're planning to attach the system.
Any other questions?